we have to draw this top view. So for that, let me take projections from A1 dash and B1 dash. Draw vertical lines like this. From A and B, draw horizontal line. From point A, horizontal line. From point B, both will meet at this point. Name those points. Here point A would be there, and here point B is there. Similarly, find out position of point C and D. From C dash and E dash, draw vertical lines. From E, horizontal line from point E, horizontal line from point C. So 2 points would be here. So we have identified 1, 2, 3 and 4 points. Name these points. This is point E and this is point C. So A, B, C and E points are found. Now about point D. So for that, from point D1 dash, draw straight vertical line, that is projection line, and from D, draw a horizontal line like this. You can show arrows like this to make it clear how you have drawn the lines. So here is point D. Name this point number D. Now whenever we are looking from top, all these points would be visible. This in case of pyramid, the base would be visible. So join all these points with a straight line like this in a sequence: A, B or A1, B1, C1, D1 to E1. One should be added to differentiate from first step to second step like this. Now think about this apex point, these slant edges. Apex point O1 dash to D1 dash, O1 dash to C1 dash, O1 dash to E1 dash. So those edges, apex point O would be somewhere here. So for that, vertical line from point O1 dash, horizontal line from point O. So here is the apex point, name it O1, and join this apex point with all the points O to E, O1 E1 with the full line, O1 C1 with the full line as it's visible, and O1 to D1 with the full line as it's visible. So this is the second step and we have finished up to this one, triangular face perpendicular to HP. Now the last step, this one, 45 degree to VP. The triangular face is making an angle of 45 degree to VP. So what should we do? So for that, here we think about this case. Here this is the triangular face A1, O1, B1, which is at right angle to XY line like this. Now we have to tilt in such a way that this angle should be 45 degree. So what should we do? So for that, we have to draw a line at an angle of 45 degree with XY line like this anywhere, and this angle is 45 degree. That is important. Anywhere you can draw this angle. Now measure this distance A1 to B1, measure this distance, put it over here and locate 2 points on this line. One is point A1 and this is point B1. So 2 points are located. Now A and B, 2 points are located over here. Now what's about rest all points? So for that, measure the distance A to E like this and take A1 as a center and draw an arc like this. Measure the distance B1 to E1 like this, take B1 as a center, draw an arc. So somewhere here point E1 would be there. Similarly, measure the distance B1 to C1 like this, B1 as a radius, draw an arc. A1 to C1, this distance as a radius, A1 center and draw an arc. So somewhere here point C1 would be there. So name that point as point number C1. Similarly, point D1 could be found by drawing arcs by measuring the distance A1 to E1 and B1 to E1. Both the distance would be same. So B1 to arc, A1 as a center, draw an arc, and point would be somewhere here. Name that point as point number D1 and join these points with the full line, same as the second step, because the visibility of line will not change whenever we tilt it with respect to xy line. Similarly, apex point would be somewhere here, that is O1. So join apex point with the respective base points D1, E1 and C1. So just we have redrawn this top view like this, such that it makes an angle of 45 degree with this xy line. This is xy line, right? Now we take projections and we can find out its front view. So for that, from A, draw a straight vertical line. From E, draw a straight vertical line. From B, vertical line. From D and from C, like this. Vertical lines from all these points A1, B1, C1, D1, E1, and horizontal lines from all these points A1 dash, D1 dash, C1 dash, D1 dash, E1 dash, and apex point O dash. Horizontal line from here. Name the respective points. So vertical line from point A, here would be point number A, or you can name A2 dash. B is here and B is here, so here is point number B2 dash. C is here, so here is point number C2 dash. Point number D is here, somewhere here, D2 dash, and point number E is here, so here somewhere E2 dash is here. And join all these points with a straight line. A, B, A1, A2 dash to B2 dash, B2 dash to C2 dash, C2 dash to D2 dash, then D2 dash to E2 dash with a straight line. And apex point is somewhere here. Here is apex point, and join that apex point with respective corners O2 dash to A2 dash, O2 dash to C2 dash, O2 dash to E2 dash, and O2 dash to D2 dash. Now what's about OB? Whether it would be visible or not. If it is invisible, it should be joined with the dotted line. And we can locate its axis like this. Its axis over here, it is somewhere here. The axis of this solid could be represented like this. One long dash, one small dash, and you can name the view as this is the front view and this is the top view of this problem. And I hope the solution of this problem is clear to you. You can see this problem, the solution. This is the top view. What we have done in this problem, first we have drawn this top view, then this front view, height is 60 mm, side length is 30 mm. Then we have tilted this front view like this, such that this A dash C dash O dash becomes perpendicular to xy line. Then we have taken the projections from this front view to here, top view to here, and we have drawn this top view in the second step. In the third step, we have tilted this top view at an angle of 45 degree with xy line, and then we have taken the projections, and this is the front view. So this is the solution of this problem, and this angle is 45 degree. Now next problem, problem number 4, and the data is given like this. A square pyramid of 50 mm sides and 140 mm height has its axis parallel to VP and inclined at 60 degree to HP. Draw its projections if one of its base edge is inclined at 30 degree to VP and the apex is on HP and 40 mm away from VP. Draw its projections. So here this is the data, and we have to shorten this data. So how to shorten this data? This is the full data which is given to us. Now think about the solution. For hints, a square pyramid is given, side length 50 mm, height 140. You have to make a practice to write the data in short form like this. Square pyramid with these dimensions. Then axis parallel to VP and 60 degree to HP. It is given axis parallel to VP. So first assume the axis perpendicular to HP. We assume this and first draw top view such that one side is at 30 degree to XY line. First you have to think this. Then apex is on HP, so tilt front view at an angle of 60 degree such that apex is on XY line, and take projections from front view to draw its top view. So these are the steps which we have to follow to solve this problem. So the first step we would draw like this. You can write the short data like this as well. Here square pyramid is given and side length, the base edge is 30 degree to VP. So we have to draw a square below XY line such that this base makes an angle of 30 degree with XY line like this. Say this angle is 30 degree angle and draw this square. Name the endpoints. Say here is point A, B, C, D, and here apex point O dash, A dash. Vertical line from point B like this would be here, vertical line from point A would be here, vertical line from point D, and projection line from point C would be here. So here is point number B dash, here is point number D dash, and here is point number C dash. Now if we are looking from this side, somewhere here, from front, this is the front view. So B is visible, hence this B point or B dash point should be joined with the apex point with full line like this, because it's visible. So O dash to B dash would be visible, right? And if you are looking from here, from this side, this D is away from us, so that D dash would be invisible. So join O dash to D dash with the dotted line like this. So O dash to D dash will be a dotted line, right? Now this we have drawn a square pyramid, 50 mm side length, 140 mm height, and axis parallel and base edge is 30 degree to VP. This we have drawn, right? Up till now it is drawn. This is also drawn. Now think about next steps. Axis parallel to VP and 60 degree to HP, right? So we have to tilt its axis such that it is parallel to VP and it makes an angle of 60 degree with VP. So for that we have to draw axis of this solid. So how to locate the axis of this square pyramid? So for that, join the opposite corners AC and BD, and it's a full lines because it shows the slant edges of this solid AC and BD, and this is apex point O, and from this O draw a center line like this, which shows the axis of this solid, and it is given that this axis makes an angle of 6 parallel to VP and 60 degree to HP, this one. So we have to tilt this axis at an angle of 60 degree with XY line, but further it is given that apex is on HP. So this apex point should be on XY line and 40 mm away from VP. So this apex should be at a distance of 40 mm from vertical plane. So this distance should be kept 40 mm, this one, and that we should take care in the first step as well. This distance is 40 mm, right? And this O dash should be on XY line. So somewhere here O dash should be there. Now we have to draw a line at an angle of 60 degree with XY line like this, and this is the axis of this solid. This is the axis having one long dash, one small dash, right? And this angle is, as it is given in the data, 60 degree, and this is apex point O dash. Now measure the distance from this front view O dash to C dash like this. Take O dash as a center, draw an arc, and we have to redraw this total front view over here like this. So its redrawing would be, I am skipping that step. You know how to redraw this front view, and here is point A dash, here is point B dash. So this line would be visible, this line would be dotted line, here is C dash, B dash, and this is D dash. So till now we have drawn this view. Now we have to draw this top view by taking projections, and you can do this exercise at your own. So I am leaving this exercise to you, how to project this top view. Just we have to take projections from all these points, A dash, B dash, C dash and D dash, vertical lines, and horizontal lines from A, B, C and D. Find out these points and join them with respective position. So let me conclude today's talk. Hints for projections of solids. These are the hints. Project from this view to get when the axis of the solid inclined to any of the projection plane, first assume the axis is perpendicular to that plane, then draw the projections in simple position. Top view first if the axis is perpendicular to VHP, and front view first if the axis is perpendicular to VP. Change the positions of the view to the given inclination. Tilt front view if the axis is inclined at HP. Tilt top view if axis is inclined to VP. Then project from this view to get the final view. Project from front view to get top view if axis at HP, and vice versa. Ensure all the points are named properly, and lowercase letters with A dash for front view and lowercase letters without dash for top view. And these are the websites through which you can get more details about this concept. www.engggraphics.wordpress.com, engineeringdrawing.org, slideshare.net and studyvilla.com, or you can communicate